Hello everyone. Today we will discuss CodeForces. Uh, so let's start. It's round 1064. The first problem is same differences. We are given with a string of length n consisting of lowercase letters. In one operation, we can select an integer I such that I is from 1 to n minus 1, that is, it is smaller than n, and change si to si plus 1. We are asked the minimum number of operation needed to make every character the same. Okay, so an important observation is the constraint of I, which is from 1 to n minus 1. That is, we can never change the nth term here. So, what do we notice? Okay, what do we notice? Okay, let's say this was the string. We notice that the last character can never be changed and the whole string needs to be converted into a single character. Whole string transformed to one character. Okay, so we can these two sentences imply that whole string transforms to the last character. Okay, so how can we do that? Start from the end. Like, let's say this was the string and this was the last two characters. Use the last character to change uh, okay, so the last second character needs to be transformed to the last character. We can do that in one operation. Let's say there were some more f's present in the middle. There is no need of an operation for these characters. Am I correct? So we can apply an operation starting from the last character, and whichever character is not equal to the last character, then apply an operation on that character with its next character. Like there was a and the next character was f, which is equal to the last character. Apply operation. So how many operations do we apply? It is equal to the number of non last characters. Okay, so the characters which are not equal to the last character, on those we apply a operation. So that is our answer. Let's go to the code part. First take the size of string as input, then the string. Iterate over the array and store the frequency of each character. And then what do we need to do? We need to print n minus, okay, frequency of non-last characters is equal to total minus frequency of last character. This gets our mission accepted. Let's move to the next question. You have been staring at your computer screen for too long. It is time to give it a break and go touch some grass. Your screen is a line of length A and there are n tabs displayed on it. You want to close all the tabs by clicking on X at the right endpoint. Each tab is a segment of length. Uh, Note this formula where m is the number of remaining tabs. The tabs that are tightly arranged in sequence from left endpoint of the string, that is x, will be length, 2 times length, 3 times length, and so on. Now the cursor is at the left end point of the screen. You wonder how many minimum number of times you need to move the mouse to close all the tabs. Okay, so there is a visualizer given here. We can use this to understand the problem. Let's say uh, there were size of A is 36 and there were 7 tabs. Okay, so how would it look like? This is it. There are 7 tabs. If we keep closing from the left, currently our mouse pointer is at the left end. Now one operation move to the leftmost tab. Now tab switches. Again an operation. Now we can cross all the tabs. Like if we keep n a bit larger. Okay, if we keep n a bit larger, let's say 15, and the length of B is let's say 5, and A is the total length of screen. Let's write it as 5. Okay, so what happens in this scenario? There are too many tabs. We close one. As soon as we close, we cannot predict how many times we move forward. After third move, we moved once. After fifth move, we move second time. Then seventh time, we move again. So, like too many moves are required for this particular scenario. While if we understand that if we move from the left end to the rightmost end, in this scenario, unless and until all the tabs can be accommodated inside the screen size, okay, they keep coming towards the rightmost end. Okay, so how can we use this for our understanding? First of all, understand that we can understand using the test cases. If you are in a contest scenario, like outputs are only ones and twos, so is it such a scenario that answer can be only one or two? If yes, what should be the scenario? Okay, so one scenario that I showed you just now was a scenario in which answer should be one. Like, let's understand what would be the scenario where answer would be two. This was our tabs. If we moved to the rightmost end once, then cross, second cross, now we saw that uh, the tabs fit inside our screen. That is, the maximum length was 2, and there are 4 more tabs. So uh, The total length is 9. So the how much window is taken by each of the screens? Like 8. Okay, because 4 tabs are there and each tab takes 2 at max. 2 length at max. Total length is 9. So one length is left over. Now, if we see that since B is fixed now, every tab takes the maximum length that it can take. So its width won't change right now. So if we move from rightmost end to the first tabs cross, we can cross all the tabs now. Okay, why is this happening? Let's understand the mathematics behind it. When is completely filled, what is the scenario? In this scenario, every win or tab takes total length divided by A is the total length and M is the number of tabs. N by M length. Okay. When screen not completely filled. Every tab takes B length because that is the maximum length that can be taken by a tab. So what is the mathematics here? How would you discriminate whether a screen is completely filled or not? Okay, so not N by M, it's actually A. A is the total length. So when A divided by M is smaller than equal to B, okay, is the scenario where the screen is completely filled because if the tab occupy more than B length, it is restricted. So the maximum length that can be taken is B. So when is tab restricted? When A by M is smaller than equal to B. And what can we write it in other terms? We can write that A by B is smaller than equal to M. So the number of tabs, where what is M? M is the number of tabs, is greater than equal to A by B, then restricted. Okay. Now, what was the algorithm that we devised for that scenario? It was unless and uh, holes until the whole screen is occupied, move our pointer to the rightmost end and click on cross. And at the very first moment, when our screen is not completely occupied, move back to the leftmost tab and just click on cross. With this way, we can always complete our crossing operation in at most two operations. So, uh, what can be the scenarios now? That initially the screen is not completely occupied. Then just the answer is 1 because take your pointer to the leftmost tab and click on cross every time. If it is completely occupied, then two scenarios. One, if B equals to uh, A, which means the restriction size is screen length. Even in this scenario, one operation would work. Just take it to the rightmost rightmost corner of the screen. The second scenario, when B is not equal to, then two operations required. Now write this in the form of code. Okay. Temp is A by B, which is equal to uh, the number of okay. Temp is equal to A by B, which is equal to the critical point at which tab switches from size A by M to B. Okay. Now, if it is already smaller than temp, that is, it is already in B part, then only one operation is required. And in the other case, if B equals A, then one operation is required. Otherwise, two operation is required. So this is it for the second question. Let's move to the third question now. So we are given n non-negative integers a1 to an arranged on a ring. For each I, AI and AJ, AI and AI plus 1 are adjacent, and A1 and AN are adjacent. We need to perform the following operation exactly n minus 1 times. Choose a pair of adjacent elements on the ring. Let their values be x and y. Merge them into a single ring of value max of x comma y with operation cost max x comma y. Note that this operation will decrease the size of ring by 1 and update the adjacent relationships accordingly. Calculate the minimum total cost to merge the rings into one element. Okay, let's analyze the question. Okay, so we are given a ring on which some elements, or let's say nodes, reside. Let's say these two nodes are neighbors, then this node, and at the end this. Okay, so uh, let's understand it with some examples. Like say we had 1132. So this is 1, this is 1, this is 3, this is 2. Okay, so first of all, let's understand what happens when we remove a node. Like let's say we decided to remove this node and this node, like apply an operation on this node and this node. So this would be merged into the max of the two nodes. So this would be removed and this would become a single node with value 2, and the cost of this operation is equal to 2. So this is what the question says. Now we need to remove all the elements, just uh, decreasing the size of ring to 1, exactly n minus 1 operations. So n minus 1 nodes are removed, so only one element is remained at the end, and we need to output the minimum total cost to remove n minus 1 elements. So the intuitive greedy idea that comes to mind is take the node with take the pair with maxi minimum cost each time. Okay, let's analyze this idea. Let's say here this one and this one are the ones with minimum cost. Okay, this particular one and this particular one are the nodes with minimum cost, because the max of both of them is 1 itself, which is the minimum cost required. If we take this node and this node, the max of both of them is 3. Similarly, if we take this node and this node, the max is 2. And this node and this node, the max is 3. So best case here is 1. Now, what happens if we remove one of them? Do it cause any harm on any of these two nodes? If we have had selected these two nodes, the minimum answer that we would have got would be equal to these nodes themselves. Okay, because at least 2 must be the answer, because if there is a number which is smaller than 2 and is paired with this 2, the max is equal to 2, so 2 cost would be required. Similarly for this 3, while here we see that these two nodes lead to a cost of 1. Now, will this removal lead to a problem in future? Let's understand this. Okay, what was this node's neighbor? When would this lead to a problem? It would lead to a problem when currently it had a smaller neighbor, while the removal due to this operation leads to a larger neighbor in future. Can this be possible? Like, let's understand it. Okay. So for understanding that, let's frame some other example. Okay, okay. So let's say this was 2, this was 1, this was 3, okay. So okay. So let's understand this example. Here, this node's cost is 1. This node's cost is 1 again. Like let's say 2 again. This node's cost is 3. This node's cost is 3. Now, the minimum pair is this 1 and this 2. Okay. This 1 and this 2. So what did we say? Problem arises for a node if removal of its neighbor changes the cost in after removal. Now let's understand with this particular 3. After removal, what happens is this 1 gets removed, this particular 1 gets removed, and this 2 becomes the neighbor of this 3. So, is the cost required with its left neighbor, or let's say a clockwise neighbor, changed? No. In this example, it is not changed because initially the cost was 3, and even now the neighbor is 2, so the cost is equal to 3 only. Can the cost change? For cost to be changed, this particular term must be smaller than the new neighbor, that is this particular cyclic neighbor that is being removed. So if this was x and this was y, then x must had to be greater than y for a change in cost. So if x is greater than y, we see that y becomes the newer pair with smallest cost, because the cost now becomes y and y is smaller than x. So this is a contradiction. We initially assumed that x is our uh, x and 1 are our smallest pair with minimum cost, and at the end we got to the conclusion that if in future some problem arises, y need to be smaller than x, which is a contradiction. So we can say that our greedy approach of logic was correct. So let's move to the implementation. Like, what would we implement for every iteration? Choose the pair with minimum cost. Okay, and after each iteration, update the neighbors. So let's go to the implementation part. So for implementation, let's first assign the left and right neighbor for each of the nodes. A cyclic neighbor can be found using this formula if it is a zero-based indexing. Similarly, right neighbor can be found using I plus 1 modulo n. Now we need the neighbors or pair with maximum, uh, minimum cost. What is the cost? Cost is max of bracket I or the current node and the next node. Let's say previous node. Okay, and uh, we would keep we would need to keep the node number as well. Let's say we always keep the rightmost node for representation. So what is the set we are creating? Set is of pair int comma int. Okay. Let's say initially answer is 0. That is the number of operations required. How many operations do we perform? N minus 1. We initially said that we always keep the right uh, element of the pair. What is the cost for current operation? It is stored in first part. Okay. What is the left now? It is left of R. These L and R are the pairs on which the operation is being performed. Let's select the T, which would be the element that is going to be removed. If the right element is greater, then the left will be removed. Else, the right one will be removed. Okay. Now, do operations to fix the updations of left and right neighbor. First, what are the pairs that will be removed? Since T is removed, its left child and its right child, or say left neighbor and right neighbor. The pair formed of T with its left neighbor will be removed. Similarly, pair formed with right neighbor will be removed. Okay. So what is that pair represented by? Max of bracket T, comma, bracket right of T, right neighbor. And since we initially decided to represent pair by index of right element, so the second element is right. If it is not, if it is present in the set, just erase it. Similarly, for the left child, or say left neighbor. Okay. Now updations are done. Now about the right child and left child of its neighbors. The right child of left neighbor equals to right child of current node now, because this element is removed. Similarly, left child of right neighbor of t equals to left neighbor of t. An extra pair is inserted now, which is the left child and right child. Okay. And at the end, just print the answer. So this is it. All the test cases are passed.